Hello and welcome to today's lesson about addition of whole numbers and decimals. First, let's talk about some important terms and vocabulary you will need to know for today's lesson. The first word is algorithm. This is a set of step-by-step directions for doing something, in this case, solving a math problem. We will look at a couple of specific types of algorithms later on in this video, so keep this word in mind. Our next term today is place value. And this is a system that gives a digit of value according to its position or place in a number. In our standard base 10 decimal system for writing numbers, each place has a value of 10 times that of the place to its right and 1/10 the value of the place to its left. If you are asked to identify the place value of a number, for example, this 3, you would say that it's in the thousands place because that's where it sits within the number. If you are asked to identify the value of a digit, for example this 9, the value of this 9 isn't really 9, it's actually 90 because it's sitting in the tens place and it's worth 9 tens. Our final term for today is expanded notation. This is a way of writing a number as the sum of the values of each digit. For example, if we use this number up above, 3,491 and 62 hundredths, we would end up with an addition problem that looks like this. 3,000 plus 400 plus 90 plus 1 plus 0.60 plus 0.02. And this is exactly what we're talking about with this definition. This is a sum of all of the parts of this number. So the first method for addition of whole numbers and decimals that we're going to talk about today is called the partial sums method. And this is basically an addition algorithm in which separate sums are computed for each place value of the numbers and then added to get a final sum. The reason that we practice this one is because it helps you be aware of the place value in relationship to addition. With this method, we're going to work from the left side of the problem over to the right side of the problem, going column by column through the numbers. The first thing we're going to do is start by adding the ones place in this case because the ones place is the largest place value that we have represented within these numbers. Second, we're going to add the tenths place because the tenths place is what happens right after the ones place in the second column of this problem. The final step for solving this problem will be to add all of the numbers in the hundredths place of this problem. Once we've added all of the three different columns of this problem together, we're going to add all three of those sums together to find the final sum for the answer to this problem. Here's how it should look while we're solving the problem. The first thing I'm going to do is add 4 plus 7 because those are my numbers in my ones place, and if you remember, I said I was going to start on the left side of this problem. 4 plus 7 is 11. So I'm going to write 11.00. I want to represent all of the places that I haven't added yet so that all of my numbers end up being the same length in the end. The next thing I'm going to do is add the tenths place and write that answer below my first answer. So 5 tenths plus 9 tenths is 14 tenths, which translates to 1.40. And the final place that I need to add is the easiest one on this problem, which is the hundredths place, and we're going to add basically 6 to nothing, so I'm going to come up with 0.06, and then I'm going to add all of those together. So now that I've done all of my adding, I am going to come back through and just add, like I said, all three of these answers together to find my final answer. 6 plus 0 is 6. 4 plus 2 zeros is 4. I'm going to bring my decimal straight down, and then I have 1 plus 1, which is 2, and 1 plus 0, technically plus 0, I just didn't write that 0 in, and that's 1, so my final answer is 12 and 46 hundredths. The second and final strategy that we're going to use today is called the column addition method, and this is an addition algorithm in which the addends digits are first added in each place value column separately, and then 10-for-1 trades are made until each column only has one digit. Lines can be drawn to separate place value columns, so it makes it a little bit more clear exactly what you're doing. So here you can see I've gone ahead and quickly just labeled the 3 different columns. I also drew some lines in to kind of show you what I meant when I said that you can draw lines to make columns in this method. Makes it a little bit easier to look at and a little bit easier to work with. So I'm going to go through, and I'm actually going to go right to left on this one because that's kind of what I'm comfortable with. I'm going to start with the 100ths place, go to the 10ths place, and then finish up with the ones place. And then I'm going to do some trading so that these 2 place values only have 1 digit in them. But the ones place might actually end up having more than 1 digit, and we'll talk about why that is at the end. So the first thing I'm going to do is add 8 plus 1, and that equals 9. Then I'm going to move over to my 10ths column, and 2 plus 9 I know is 11. I'm going to write the whole number in that column. And finally I have 5 plus 6, which also equals 11. And then we've got a decimal place that we've got to carry down there as well. Now since I have in my 10ths column this number that is 2 digits long and I can really only have 1 digit in there, I need to do my 10 for 1 trade. And basically what that means is I'm going to take 10 away from this number and trade it and send it over to this number, because what 11/10ths really is 1 and 1/10. That's what it really stands for. So when I trade that, I am going to, first I'm going to extend these lines down, and then I'm going to end up bringing my 9 down. That's going to stay exactly the same. This 11 is going to become a 1 because now I've taken 10 away from it. I'm going to put my decimal in just like I did last time, and then I'm going to add 1 to what was originally 11, making it now 12. So my answer for this problem is going to be 12 and 1900ths. And the reason that this ones category gets to have 2 digits, like we talked about a couple of minutes ago, is because really what we're looking at is, if we drew another line in here, the ones place all of a sudden doesn't have 2 digits. It only has 2 digits. I'm sorry. It only has 1, making this new number that we have over here part of the tens place. Here is your practice problem for the day. Using any of the methods that we talked about today, or any other method that you may be comfortable with, use these 2 add-ins, 8 and 4100ths and 9 and 8300ths, to find the sum of the digits.